Okay, we're going to start Unit 8 material. It's on sine functions, sinusoidal functions, which basically means any kind of situation that repeats over and over again. So for example, if you were on a Ferris wheel, you'd start on the ground, you'd go around up to the top, back to the ground, back to the top, back to the ground, and round and round and round. Or imagine if you were on a swing, you push a kid on a swing, they start in the middle, you push them, they go one way, they swing back to the middle, as far backwards, back to the middle, and so on. It just keeps swinging back and forth. So anything that repeats over and over, we call it a periodic function, and it's represented by a sine equation, and we'll get to that later on. So to start with, we're going to learn a new way to measure. So we're going to look at radians, and our radian measurement is just like different units instead of using degrees. So for example, we know that you can measure somebody's weight by using kilograms, or you could use pounds, or you could do temperature in Celsius or Fahrenheit. So it works sort of the same way that you can measure angles in degrees, or you can do radians. The reason why we're going to pick radians is it's going to work way better for when we do regression, and if we do any kind of modeling of real life situations and using formulas and so on. Anytime we do that, the radians work way better, and your calculator is sort of set to use radians, so that's why we'll do it. You can change your mode on your calculator to be in radians. When you go to mode, just pick radian instead of degrees, and you can leave it like that. You can leave it like that, and when you go to write the diploma and they reset your calculator, it automatically goes to radians, and you can just leave it like that for the entire diploma. You won't need to do any changing. Okay, so to start, we're going to figure out what a radian is and how it compares to degrees. So you should know from before when you do degrees that if we start on, like in terms of a quadrant, if we start at the 0 position and we go in a circular pattern, we'd measure from 0 up to 90 degrees would be something like that. And if we keep going, a 180 would be all the way around to the other side of the circle. And if we go another halfway around, we get to 270. And then we'd be right back to 360 at the start. So in terms of degrees, we sort of measure from 0 to 360, and we can go around and around the circle as many times as we want. So for example, if we were to draw 45 degrees, that would be something like that. If we were to draw 150 degrees, it'd be somewhere over here. And if we were to do 260 degrees, it's down low like that, and so on. And if I said that we could go 500 degrees, you just go around to 360 and keep on going another 140 degrees, so it'd be, somewhere over here would be 500. So we can do angles in a circle, just like that, and it works fine. But what we are going to do is figure out how does this work in terms of radians. So because we're sort of going around and around in a circle, it makes sense that radians have to do with pi. So just like in a circle, when you do area of a circle, it's pi r squared, or you do circumference of a circle, it's 2 pi times the radius. So the same sort of thing works for radian measure. If we actually do one complete revolution, so if we start at 0 and we make one complete revolution, it's actually 2 pi radians. And you don't need to know the pi terms, we just want the approximate decimal. So 2 pi radians is actually about 6.3. So if you go 2 times 3.14, you get around 6.3. So that's what it is in radians. Okay, and so that means if we went 2 pi to go all the way around the circle, halfway around the circle would be 1 pi, or like 3.14 radians. And if we do a quarter of the circle, so that'd be like half a pi, or 0.5 pi radians, which works out, if you multiply those out, you get roughly about 1.5 radians. Okay, so we have 1.5 to go one circle, a little bit over 3.1 to go half a circle, 3/4 of the way around works out to 4.6, and then back to 6.3 when we get all the way around. So it's just a different mindset. You got to think of radians as being sort of like degrees, except we're basically going from 0 to 6 instead of 0 to 360 in terms of degrees. So they don't have to be exact. Like I said, it's going to be approximately 6, and you'll see on your calculator in a bit how that's going to work. So it's just an easy way to sort of compare these things. So for example, if I said 120 degrees, So we could take 120 degrees and we can actually figure out the radians by going, if we know that 180 degrees equals 1 pi, we can just go 120 divided by 180 and times it by pi. And if you do that on your calculator, you get about 2.1 radians. So does that make sense? Yeah, it looks pretty close, because 120 degrees would be, so there's 90, so 120 is right about there. And if it's 1.5 radians to get to 90, 2.1 makes sense. So it looks good that 120 would be 2.1 radians. Okay, and we could do it the other way around. If I said what is 4 radians, you could always convert by just doing the opposite. So you'd go 180 times 4, or let's do it the other way around. Let's go 4 times 180, right? Well, we did 120 divided by 180, so to go the other way, you'd go 4 times 180, and then you divide by pi instead of timesing by pi. So if you did that, 4 radians works out to about 230 degrees, I think, roughly. I didn't calculate it exactly, but it's somewhere in that neighborhood. So you can see that that makes sense too, because 230 would be right about in the middle, so 4 is kind of halfway between 3.1 and 4.6. So that's it. So that's kind of what a radian is. You don't need to worry about the conversions. You're not going to get questions where it says how many degrees is a radian or whatever. What you have to be aware of is that going around a circle, let me just kind of move on here. So if we're going around a circle, you just have to realize that we're going to go from roughly 0 radians to 1.5 approximately, to 3, to 4.5, and back to 6, and so on. It'll just keep repeating around and around just like that. Okay, so what we're going to do now is we're going to look at how radians work in terms of our graphs and what this actually means. So like I said, every periodic function we're going to use a sine graph to represent that. And we're going to look, next week, we're going to look at different examples and kind of get more detail of how they work. But so for today, we'll just look at the basic graph. So on your calculator, if you're in radian mode, you graph y equals sine x. You don't have to really change your window setting much. You can maybe make your x a little bit bigger. So like I've got on the screen here, it goes from 1 to -1. So maybe on your calculator, if you go 2 to -2 in the y direction, in the x direction, you can just go by tens or whatever, will be fine. So if you graph this on your calculator, what you're going to see is the graph kind of does a repetition kind of wave pattern. So it starts at the origin, and the graph will go up to 1 will be the maximum, and it's going to go over to about 3.4 or 3.14 where pi is, will be the next intersection point. So the graph ends up doing a wave like that. And then just like we had on the previous thing, from 180 degrees or 1 pi, it then goes back around to 0 again. So if we actually go over to 6 radians, so 6.2, so a little bit past that, then our graph does the same thing but in the negative direction. So that's one complete revolution of the graph. So we get one wave going from start to roughly 6 radians, a little bit over 6 radians for one cycle of the graph. And then from there it's just going to repeat over and over again forever in both directions. Okay, so the graph will just keep making these wave sort of patterns, and it'll go on and on depending on what you want. Obviously, if it was a situation where we're dealing with time or something like that, then we wouldn't worry about any of the negative graphs, right? Our graph on the negative side would be gone because we can't have negative time. And we're going to see next week that we're going to have these graphs shifted upwards so that we only have positive heights and things like that. You're going to get the graph shifted left and right and so on. But that'll be next week's stuff. So what we want to worry about for now is basically just looking at the graph and kind of seeing what one cycle looks like and sort of what happens. So we'll just kind of re-highlight this graph. So one complete cycle goes like that. So it has a height of 1 and a low spot of 1, and we have our, in terms of radians, we go from 0 to 3 to about 6 for the other side, and you can see our heights. When we hit our maximum height, that's roughly at 1.5, so that's where our 90 degrees was, and the dip on the other side is roughly at 4.5. and that's where our 270 degrees was. So this graph matches our circle pretty accurately in terms of going around and around and around. If we were to do this graph, just to kind of compare it, if you were to do this graph in degrees, the graph would still look the same. So you'd still have y equals sine x, and you do it in degrees. So if you sketched it on your calculator, you would get the same thing, but if you just type it in the way it is in degree mode, it just jumbles it all up, because our window setting would have to be changed, because we're going from 0 to 360. So our axis, instead of being 0, 1, 2, 3, 4, 5, 6, we have to go to 0 to 360 degrees, and then our middle would be at 180, and so on. So you would get the exact same graph, but you have to mess up your window setting, and that's why we tend to not do that. We just stick with it in just radians, and then we just worry about regular numbers instead. Okay, so let's go back to what our regular y equals sine graph looks like, and I'm just going to draw one section of it. I'm going to enlarge it a little bit. So let's suppose that was our graph. Okay, and let's just look at some different components of the graph that you have to be aware of in terms of definitions. So the first one is, you have to know where the midline is, and the midline is just the location that would cut that graph in half, just like it sounds. So it'd be the line that cuts this thing in half, halfway up, halfway down. So in this case, our midline is basically the x-axis, right? The regular y equals sine x, the x-axis would be what divides that in half. Okay. The next one you have to know is what's the amplitude, and it's named amplitude. It's basically to describe the height of the wave, but we don't want the total height, we just want sort of the distance from the midline up to the peak, or you could measure it from the midline down to the dip. It's the same height, right? It goes up 1 or down -1, so it'd be the exact same height. So the reason I use the word amplitude, it's based on sound waves. If you have an amplitude or you amplify music, all you do is you make that height of the wave bigger, so that's why it sounds louder. The other definition that we have to worry about, so midline, we got our amplitude, so I called it A in the diagram. The other one that we have to do is period, and the period is the length for one cycle. So one complete cycle is what describes the period. So in this case, the period would be from start to finish. So it would be the distance. So the period would be the distance from start to finish. So in this case, the green line that I've got labeled would show the period. Or it would also be, you can measure the period in any chunk of the graph as long as it's one complete cycle. So if I was to complete this graph in the negative direction, it would be the distance from peak to peak, or trough to trough, and so on. Okay, so the period, like I said, we could go any section of the graph as long as it repeats. So from peak to peak, or trough to trough, or middle to middle, like I drew it here with the green arrow, whichever. The period is just any cycle, one complete cycle of the graph. And that'll be it for this first part. So basically the main idea is being able to work with radians, do it on your calculator, and then to understand sort of how a sine graph looks and what are the key things, the midline, the amplitude, and the period. And in our next lesson we'll look at how the equation works and what do those midline, amplitude, and period do in terms of the equation. So if we were to look at another graph, so for example we're going to do questions something like, you get on a Ferris wheel and the Ferris wheel goes up, down to as low as it's going to go, as high as it's going to go, and so on. So you'd get sort of a repetition pattern like that. So from that we'll have to figure out what the sine equation is, and we'll need to know the midline. So the midline of the graph we'll need to know, we need to know the amplitude, and we need to know the period. So those kind of three key things of the graph we'll be using in the new stuff next week. But that's it for now.